Um, are there any questions so far? I heard someone, but then I couldn't understand it. Was there a question? Or maybe it just unmuted? Okay. We started the review on review 4. Because I wanted to do a couple since it was on Wednesday's attendance problem. So I wanted to do a couple more here, then we'll go to 3, 6, and 7. Someone's having a fire drill. I'm hoping to go over everything from the review. Normally I do get done with it in 3 hours, but I think that I don't know why I didn't. But anyways, I think I should get through everything today. If I don't, we'll finish it on Monday. So then, of course, all the homework wouldn't be necessarily due. But also with the homework, you can do it. Like if you don't get it all done on Sunday, you still can keep working on it. And it will still give you full credit. You have until the last day of class. It's marked on the syllabus. I forget the exact date that you have till. Someone had a question on that. Yeah. And you can always keep going back to it, but hopefully we cover everything today. Number 15. Now these ones, notice that you have a squared term. Squared minus 36 equals 0. When you have a squared term, you need to factor it. Or we could use the quadratic formula. On this one, it's a couple ways you can do it. You could use the quadratic formula. That always works. When you have a squared term, but not an x term, you could solve by the square root method. Or you could solve by factoring. I'll show you factoring and we could do all 3 on this one. That way you see all 3. We've used factoring the last 2 times. If we were going to factor this, the first thing we could notice is we could pull a 4 out of here. Now, since you have an equal sign, you can actually divide it out and get rid of it so you don't have to worry about it. If you were like in the first section having to factor, then you would factor it out. If you have an equal sign and you're solving, you can divide and get rid of it. Then we can factor. This is the difference of squares because 9 is 3 squared. So it would be x minus 3 and x plus 3. And you could set each of them equal to 0 and solve. Add the 3 over subtract the 3. And you get a positive and a negative 3. So one way of doing it is factoring. There's also what's called the square root method. The square root method, you get the x squared by itself first. So if we had the 4x squared minus 36 equals 0, we would add the 36 to the other side to get this by itself. We still need to get the x squared by itself, so we would divide by the 4. Now remember, you can only use this when you have a squared term, but not the x to the first. Or if you had a quantity squared, which I don't think we'll get into those. Okay, so to get x by itself, you can take the square root of both sides. The square root of x squared is just x, and the square root of 9 is 3. Notice I don't have all my answers, and sometimes that's what happens when you use the square root method is you forget. If you take the square root of both sides, it can leave a positive or a negative answer. So it's positive or negative 3, because positive 3 squared is 9 and negative 3 squared is a positive 9. So if you take an even root to both sides, it leaves a positive and a negative answer. If you're comfortable with just factoring, you don't have to use this method. The other method, when something will not factor, or you can't find the factor for it, you can use the quadratic formula. The nice thing about the quadratic formula, unless you get a negative under a radical, it always works. And if you get a negative under a radical, there's no real solution. So this one always works. These two depends on the problem. So if you only want to learn one way, learn the quadratic formula. If you don't have it memorized, it's something you should memorize. Negative b, I will let you have a formula sheet though, simply because when you're taking an exam, I can't tell if you have a formula sheet or not. So I might as well allow everyone to use one. So the formula is negative b plus or minus the square root b squared minus 4ac all over 2a. Now a, b, and c, well, what are they? A is in front of your squared term. B is the value in front of the x term, and c is the constant once it's set equal to 0. So your equation would have to be set equal to 0 already. If it's not, you'd have to get it set equal to 0. Just like we did last class when we factored, we got it set equal to 0 first. So we had 4x squared minus 36 equals 0. And we're going to plug it into this equation. A is in front of our squared term, so a is 4. There is no x to the first power, so then what is b? Anyone?
0.
When there's no value, it's 0. And then your constant, you want to make sure you take the sign with it. So it's a negative 36. So we would plug these into this equation. So a negative b will be 0, so we don't have to have that there. 0 squared minus 4 times a times c. All over 2 times a. Any questions on plugging it in? Where's my calculator? Oh, no, I didn't bring my calculator. Okay. So 16. So if I multiply this together, 4 times 4 is 16 times 36 is 576. And this negative times this negative makes it a positive. And of course, the 0 just drops out with an 8 in the bottom. And this value was also 0. Now for square root, here we go. So for the square root of 576, we get 24. So in either case, you're going to get the same answer. It's up to you which way you want to work it. This is important to know because sometimes it's not factorable and you're going to get decimals. You have to be able to use this. The factoring or the other method, that's up to you. I mean, sometimes these are quicker, but you're going to have a calculator. So plugging the values into a calculator goes pretty quickly. Is there any questions on that? So this method is important. The other two, I always try factoring. If I can't factor, then I go to the quadratic formula. So if the numbers are too big and you can't figure out a factor, this always works. And it always takes the same amount of time. Any questions on that one? Is 0. Okay. So B is with the X term. There's no term with just an X to the first power. C is the constant. It has no variable. So this is the one that's missing. This is the one that's 0. If there was an X term and no constant, then you would use that one for B. Any questions on that? Mm, 17. No, there it is, 17. 17 looks complicated because notice there's not 3 terms. 12y squared. Again, there's a lot of ways you can do it. 12y squared minus 48y equals 0. Square root method is not one of them because it has a y term. You could use the quadratic. This would be your a, this would be b, and c would be 0. Or we can factor. I would get rid of this 12 first because I noticed that 12 goes into both of these evenly. So I would divide everything by 12. Anytime I can make my number smaller, I do. Now, would you try and factor or would you use the quadratic formula? Any preference? Because there's not 3 terms, a lot of times students get confused on factoring it, but it's actually a pretty easy one to factor because if you look at the 2 terms, what do they have in common that we could factor out? Anyone?
Y.
We can pull a y out. If we pull a y out here, we'd have y because y times y is y squared. And if we pull the y here, we have a -4. Once it's factored, we can set both of those equal to 0. Y equals 0 and y -4 equals 0. This would be an answer. This one, we would add the 4 to the other side to get y equals 4. When your degree is 2, you should get 2 answers. Sometimes it's a double root. That means you get 3. Like if we got 4 here and here, that can happen. But in most cases, squared would be 2 separate answers. Any questions on that? Do you want to see the quadratic formula with it or any questions? No? Okay. Number 20. Okay, so 3 terms, looks like we would want to factor it. It's set equal to 0. So to factor it, we want 2 numbers when we multiply, we get a -1, that when we add, we get a +1. Are there 2 numbers that when you multiply, you get a -1, that when you add, you get a +1? Nope, there isn't. So this one's not factorable. And this is a case where you need to know how to use the quadratic formula then. So since this will not factor, we have to use the quadratic formula. So A is the value in front of your squared term. Remember, when there's no number, it's a 1. So A would be 1. B is in front of the x to the first. In this case, p to the first. So it would also be 1. And C is the constant. It's a -1. But always remember, you have to have it set equal to 0. So if there's values over here, you need to bring them over first. So C would be a -1. B plus or minus the square root b squared minus 4 times a and c. So plugging in, you should have -1 plus or minus the square root 1 squared minus 4 times a times c all over 2a. -1 plus or minus the square root. So negative, negative, this is 4 plus 1 is 5 all over 2. So it's a -1 plus or minus the square root of 5 over 2. Any questions on that? Yes, this is from your review 4. Is there any questions on that? Okay, so this section is just solving by factoring. I think there was one, yeah. Before we do this one, we have to do review 3 though. 1, 2, 3. Number 1. Oh. I'll give you some rules before when you're dividing variables and multiplying, we talked about the multiplication already. When we're multiplying variables, we add the exponents, and we've talked about this one. Well, this section gets into dividing. When you're dividing with the same base, you subtract your exponents, top minus bottom.
For the first rule, you said that you would multiply the exponents. I thought you would add them.
Oh shoot, thank you. I'm sorry. Yes. When you're multiplying your bases, you add your exponents. And when you're dividing, you subtract, and it's the top minus the bottom. Thank you. I was thinking faster than I was talking. This should be a plus sign. If you have, when you subtract, if you end up with a negative exponent, there's more negatives in 6 and 7 than there isn't. I don't know if any of them end up negative here, but just in case we do end up with a negative, when you subtract them, it's not reduced if you have a negative exponent. To make it positive, it'll move down, or if it's down, when you move it up, it changes your sign of your exponent. So this would be 1 over x to the n. If you had 5 over x to the negative 3, y to the negative 2. If it's in the top and it's negative, to make it positive, you move down. It just changes the sign on the exponent. This one is negative. If I move it up, it makes it positive. The 5 doesn't go with the y. This is 5 to the first power. If it was going to be to the -2, then this would have had to have been in parentheses. So you should always end with positive exponents. And to do that, you just move it into the denominator or the numerator. But moving a variable up or down changes the sign of the exponent. And I don't think we get into this one here, but I'll give it to you so you have all your rules together. Anything to the 0 power is 1. So x squared plus 6x minus 9. If all that is to the 0 power, it is just 1. Anything to the 0 power. Let me give you the radical rules too, so you have them all together. A fractional exponent, this n in the denominator, that's a radical. So if we had 25 to the 1/2, that would mean the square root of 25. And we know the square root of 25 is 5. So radicals are the denominator of your exponent. If we had x to the 2/3, that would mean the cubed root of x squared. So the radical's the denominator, the exponent is the number on top. So this would mean to square your number and then take the cubed root. These are in, I think, review 7. But that way you have all your formulas together. Okay, so we'll try number 1. Now, if 3 and 35 could reduce, you would, but 3 won't go into 35, so it doesn't reduce. But we can reduce the v's. 2 ways you can think of it. There's 2 on top and 1 on the bottom, so I'm canceling 1 and leaving 1 on the top. If we use the rule, it would be top minus bottom. And when there's no variable in the exponent, remember, it's a 1. So this would be v to the first. So it would be 3v over 35, or you could write it 3/5.
It's a 5, not a 3.
Oh my gosh. Sorry. I don't know why my glasses were reading it as a 3. And then it will reduce. We'll reduce it next. Now, when you're writing it, you can write it as one fraction, or you could write it 5/35V. Now, we're going to reduce the 5/35, but. So both of these are correct answers. Well, except MyMathLab would tell you, you haven't reduced your fraction. To reduce it, both of these are divisible by 5. So it would be 1/7V, or you could put V/7, or 1V/7. All of these are correct. And MyMathLab will take all of these. This one, they would tell you it needs to be reduced. Any questions on that? Seven. No. Oh, yeah, we'll try number 7.
I'm sorry, could I please see that one more time?
Sure can.
Okay, wait, so. Okay, thank you.
Are you sure? Did you have a question on it, or you just needed to see?
I mean, why wouldn't it just be 7V? Because like, wouldn't that just go into it evenly, kind of?
Okay. Well, the 7 is in the denominator. So it
Okay.
has to stay in the bottom.
I gotcha. All right, thank you.
You're welcome. Number 7. Now, number 7, you cannot just cancel those m squareds. Your quantities need to be multiplied together. If you look at the first one we did, notice that 5v squared, that's all multiplied together. 35v, that's multiplied together. So we could just cancel. But these have separate terms. When you have separate terms, you can't just cancel them. You have to factor first. So we need to factor the top and the bottom. Then if they have like quantities, you can cancel them. So when you have separate terms, you can't just cancel. We have 3 terms on the top, 3 on the bottom. The only way we could cancel if something went into all of them. But nothing goes into all of these. Have to factor. We need 2 numbers. When we multiply, we get a 4. That when we add, we get -4. What would those be? -2 and +2. Well, no. 2 negatives, right? Yeah. -2 and -2. Negative times negatives gives us the +4. When we add them, we get a -4. So it's m-2 and m-2. Now the same thing with the -6. What's 2 numbers? When we multiply, we get a -6. That when we add, we get a +1. One person said 3 and -2. Notice when we multiply, we get a -6. And when we add those, we get a +1. So that's exactly right. A lot of times when they're having you do these exercises, you want them to cancel. So you need to have an m-2. So always try that. one of the m minus 2's on top cancels with the one on the bottom and leaves m minus 2 over m plus 3. There's 4 separate terms. You cannot cancel these m's. If you want to leave the parentheses so that you remember it has to go together. Any questions on that? Number 19. Okay, so notice there we go. We have this fraction divided by this one. When you're dividing two fractions, you can make it a multiplication by flipping the second fraction. When you have multiplication, like number 15, I would cancel stuff first, but when you have multiplication, you can just multiply across. So 13, we could just multiply these across, then simplify. But division, you have to flip the second fraction and then multiply. Now it's up to you if you want to flip it first or if you want to factor first and then flip it. But in either case, one, we're going to have to factor because of the quantities. And we have to flip it. I'm going to write the problem real quick though. So if you want to start factoring it, you can. So this is going to say in the same order. Now there's no squared term, but we can pull a value out. Notice 4 goes into both of these. So we could pull out a 4 and have a plus 3. And this one we can pull out a 2 and have a minus 5. Any questions on that part? Now I'm going to flip this, which makes this a multiplication. I'm going to factor at the same time. So we can make this division a multiplication by flipping this. Now looking at this first one, it's a difference of squares, a squared minus 3 squared. A minus 3, a plus 3. Any questions so far? Two numbers, when we multiply, we get a negative 20, that when we add, we get negative 1. 5 and 4. Negative 5 and a positive 4. Negative 5 times 4 is the negative 20. Add them and we get the negative 1. So a minus 5 and a plus 4. Now, when you're reducing, you have to cancel from the top and the bottom. They can't be next to each other. So if this a minus 5 was on top, these would not cancel. You have to take one from the bottom and one from the top. So the a minus 5s will cancel. This a plus 3 cancels. And 4 halves will reduce. This will be a 1 and this will be a 2. Any questions on that part? So we have a 2 times a plus 4 on top. And on the bottom, 1, which we don't have to show, times a minus 3. Any questions on that? So division, you have to flip, and then multiplication, you just reduce first and multiply. Now, the difference between those and addition and subtraction, like if we look at number 29, in order to add or subtract, the denominators need to be the same. So you take, well, this one's already, these won't factor. But if we looked at like 33, 34, you'd have to factor first. We don't, yeah, I did mark 34. So if we look at this problem, our common denominator would be both of these two, because this quantity has to go together. So our denominator would be m times m minus 1. This one only has m minus 1. So to get a common denominator, we need the m. We would multiply the top and the bottom by m. Because when you have a fraction, so that we don't change it, whatever we do to the top, we have to do to the bottom. So we're going to multiply by m over m. This one has the m, it needs the m minus 1. But whatever you do to the bottom, you have to do to the top. Any questions on that part? So then we have m. For this one, this would be 1m. And then distributing our 2, we have plus 2m minus 2. Now you combine like terms. M plus 2m is 3m minus 2 over m times m minus 1. You could try and factor the top. For instance, if this was a 3, we could factor out a 3 and the m minus 1s would cancel. But since this will not factor, you can leave it in this form. Any questions on that? Okay. Is everyone all right with these, or do we need to do another one? I can't hear for some reason. It's really soft. We'll do one more. Number 34. So for number 34, I'm going to factor it while we're doing it, just to save time. In order to combine them, they need to have the same denominator, and these two do not. So I'm going to factor them. The first one, y squared plus 2y minus 3. So we need two numbers. When we multiply, we get a -3. When we add, we get a 2. So +3, -1. Because when we multiply, we get the -3. When we add, we get the +2. Minus 1 over +3, +1. 3 times 1 is 3. 3 plus 1 is 4. Now, what's nice in section 4, when you have these, because you have an equation, you can actually get rid of the fractions. But in this section, you have to keep them. Take one of everything. So our denominator is going to be the y plus 3, y minus 1, and y plus 1. So we need one of each. I didn't repeat this one because I already had it. So in the first one, I'm missing the y plus 1. So I'm going to multiply top and bottom times y plus 1. This one, I'm missing the y minus 1. I have the y plus 1 and the y plus 3. So I'm going to multiply the top by y minus 1. Now we could FOIL it at the same time. We could distribute this y. Y times y is y squared. Y times 1 is plus y. But what you have to be careful of, this is a minus sign here. So you're actually distributing a -1. That negative has to distribute through this. So when we distribute, we'd have a -y plus 1. Combining the top, the y's cancel. Now, what you need to be careful of, this is a +1, so this will not factor as perfect squares. If it was a -1, it would. But because it's a +1, it does not factor. It cannot simplify any further. Any questions on that?
So when we're doing our homework, we can just put in the denominator as it is factored and we don't have to like remultiply it out.
Correct. At least last year, they didn't require you to multiply it out. If they do require you to multiply it out, send me a picture of this because I don't want you spending time multiplying all this out. It's too easy to make careless mistakes. And I can grade it easier if it's in this form. So if they will not accept this, send me a picture and I would give you credit for it. But last year they took it factored. Sometimes they change some of the grading. Is there any questions on that? It's 10 to. We didn't do review 6 and 7 yet. I just can't see rushing, and there were some different problems I wanted to make sure we did. So we will do this on Monday. Make sure to get review the first 2 groups in My Math Lab done, but the review 6 and 7 problems, I'm just going to change the date to next week. Because when I met with, oh, don't forget to do your introduce yourself. But when I met with a lot of students, they were nervous about the algebra and the math part of it. And so I want to make sure you understand these. Not that we're going to run into it a lot, but the review is important. So I didn't want to rush through it and just do 1 or 2 problems in each. So we'll do this on Monday.
If
So
I
I'll
have
move that
forwarded
part.
it, is it okay?
Say that again. Oh, if you already did it?
Yeah, is that
Yeah.
is that okay?
No, definitely. You could always work ahead if it's up there.
Okay.
Yeah, definitely. No, that's fine. As long as you understood the problems and you're getting them right, that's great.
All right.
Mhm. And I do have videos up there on As You Learn. Yeah, on As You Learn. Oh, it's under the weekly checklist. There's videos of me doing different problems also. So you could always look there if you want to work ahead. But this one, I will change the date to the following Sunday. Any questions on anything?
Hey, I do
Well-
have a question.